So let's do a quick review of solving some basic logarithmic equations. These are the type that you will see in calculus. So the idea is very similar to solving exponential equations. We want to isolate the logarithmic expression. That's going to be our first step. All right. And then the most popular way of solving is to rewrite the equation then in exponential form and go from there. So let's look at a couple basic examples here. So if I want to solve the equation log base 3 of x equals 5. Okay. I can see that my logarithm is isolated on one side. On the other side, I have a number. Perfect. Okay, step 1 is done. Second step is to rewrite it in exponential form. So remember, every logarithmic equation has an equivalent exponential form. And exponential form means I need to start with a base. So the base of my exponential expression is 3. If you remember, a logarithm is an exponent. So this is my exponent on my base. So I'm going to say 3 to the 5th then equals x. Remember, this number here is the result of raising 3 to some power to get that x. Okay, now here's the way I look at it. I think, okay, start with the base. This is the exponent. This is the result. So you kind of roll around there in almost a full circle. One of my students called it rolling the log. All right, now look, how sweet is this? X is 3 to the 5th. So x is 3 to the 5th, which is 243. Okay, we should always go back and check our equations or our solutions to log equations because we can get extraneous solutions. Although most of the type that we do in calculus, that does not happen, but we should check. Is the log base 3 of 243 equal to 5? My biggest concern is this number must be positive because the domain of a logarithmic function is only positive real numbers. So you could put this in your calculator using the change of base if you want to check, but I can see that it's going to be okay. All right, let's look at another one. Fairly basic. So how about something like this? Log of 3x plus 1 is equal to 2. Okay. So once again, logarithmic expression is isolated. I've got a number on the other side. I'm ready to go to step 2, which would be rewrite the equation in exponential form. Okay, now this one's tricky because there is no base. If there is no base, remember it is a common logarithm. It's assumed that that is a 10. Okay, so you've got to know the difference there. So exponential form would be, what's my base? 10 to the second power should give me 3x plus 1. And then I have a nice linear equation that I can solve using basic algebra. So 10 squared is 100. Isolate the x term and then divide by 3. So I end up with x equals 33. All right. My biggest concern is when I put this back into my original equation, I want to make sure that the argument of my logarithm evaluates out to be a positive number, which it should. 3 times 33 is 99 plus 1 is 100. It's positive. Okay, let's look at solving a basic logarithmic equation involving natural logarithms. You see these most often in calculus. Okay, once again, I'm going to start by isolating my logarithmic expression. So I need to get rid of the 4. That's the logarithm is being multiplied by 4, so I'm going to divide both sides by 4. So I end up with natural log of x equals negative 1/2. Okay, here's where I'm going to go to exponential form now as one way of looking at it. The one thing that I find students have difficulty with is natural log because you don't see a base. So if you need to rewrite it instead of ln, natural log base e of x, then do so, then go to exponential form. Okay, so exponential form, you need a base. Base on natural log is e. So that becomes e. We need a power. So that would be e to the negative 1/2 power gives me x. There's my equation. E to the negative 1/2 is equal to x. Okay, and that's my solution. That's my exact value. A lot of times we leave it like that in calculus. You could also rewrite that with a positive exponent. That would be 1 over e to the 1/2. And you could also then make that 1/2. Remember, power of 1/2 is a square root. You see that a lot as well. So all three of those are acceptable answers. It just depends on what you're asked to give the form in. But they're all exact answers, and that's what you want to be able to give. No touching your calculator on this. Okay, now I want to check this for a reason because there's some cool properties we can check out. So go back to the original equation, and in place of x, we're going to put, I'm going to leave it as my original here for a reason. Okay, so if I replace that, then I get 4 times the natural log of e to the negative 1/2 is equal to negative 2. That's what I'm trying to figure out. Does the left equal the right? Okay. When I do this logarithm, this is one of our inverse properties of logarithms. That's log base e of e to the negative 1/2. If you recall, a logarithm is an exponent. So we're saying, what's the exponent on base e that gives me e to the negative 1/2? Well, when these bases are the same, come on, switch colors. These bases are the same, then your logarithm is just that exponent. So that logarithm would evaluate, the natural log of e to the negative 1/2 evaluates out to negative 1/2. So then we're trying to see, is 4 times negative 1/2 equal to negative 2, which it is. Okay, so some cool properties we can review while we're checking. Okay, let's look at one more, and then we can look at the alternative form there. Oops, let me take this with me. Okay. One more. So when I say alternative form, I mean that we had an or here. I'll show you the other one because the second method I do see quite a bit. I don't know if textbooks do it as often, but it's a good method, and you might use that in calculus at times. So I'll show you that alternative version. All right. So last one would be something like 2 times the natural log of 3x is equal to 4. Okay. All right. So once again, isolate my logarithmic expression. So I'm going to divide by 2. So I get natural log of 3x is equal to 2. Okay. Now, here's where I can go. Step 2, I can go a couple ways. The first one is what we've been doing, rewrite it in exponential form. Remember the base on natural log is e. So I can say e to the second power is 3x, and then I can solve that equation for x. Okay, so that would give me then, I have to divide by 3. That would give me e squared divided by 3. Which is my exact value. I want to leave it like that. Okay. Here's the alternative version, which I don't really know a way to say it. I just say exponentiate both sides, which basically means take both sides and make those the exponent on whatever base this logarithm has, because that inverse property will come into play again. So because it's natural log, it's base e, then I'm going to say I'm going to take both sides. My new equation is both sides are going to have base e, and those expressions will be now in my exponent. So this will be e to the natural log of 3x is equal to e squared. This is a nice review of those inverse properties again. This is one of those inverse properties which says, because exponential functions and logarithmic functions are inverses. So one is undoing the other. So the property says a to the log base a of x is equal to x. Okay, so notice this logarithm and this exponential have the same base. So one undoes the other and you go right back to where you started. Okay, so I have to recognize that natural log is base e. This is base e. So e to the natural log of 3x is going to be 3x. And you get to the same place. So it depends what you learned and what you're comfortable with. Either method is acceptable. So there's a quick review of some of these logarithmic equations that you will be solving in my math lab, and you will see these types of equations in calculus.